Alrighty, so today we're going to have a look at doing some more association with two-way tables, except this time we haven't been given organized data, we've actually been given perfectly raw data. So the following data represents the results obtained on a particular test marked out at 40, taken by two groups. Group A, which was 16-year-olds, whereas Group B were 18-year-olds. The pass mark for the test is 25. To determine whether there is an association between age and the likelihood of passing the test. So, we've got two variables. We've got age and we've got passing the test. So that's pretty helpful because we're basically going to split our age into two groups, being what is the younger group, Group A, and the older group being Group B. Group B. Whereas with the passing test, where we can split that into two groups, the ones who pass and the ones who fail. And we're going to have to organize our numbers so that anyone who passes, which is going to be over 25, go in one group, whereas all the ones that go in the other. So age and passing the test. So which is our explanatory variable and which is our response variable? Well, for me, I think that age has got a pretty good chance on explaining whether someone passes the test or not. Alternatively, you can think, well, passing the test is going to respond to the age of the student. And this is a hypothesis. We don't know that this is true yet, and we don't know which way it's going to go. But the idea is that we can start to have a think about it. So let's organize ourselves into a two-way table. Alrighty, so we can currently go through and work out how many people passed and how many people failed from each of these. You notice I've put age on the top, or being the groups, and then pass and fail on the left. So let's count how many passed. Well, from Group A, 37 is a pass, 26 is a pass, 31 is a pass, 23 is a fail, 34 is a pass, 38 is a pass, 29 is a pass, 17 is a fail, 33 is a pass, 26 is a pass, 23 is a fail, 21 is a fail, 29 is a pass, 30 is a pass, 33. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 who passed from Group A, and that means that there are 1, 2, 3, 4 who failed from Group A. Total of 15 people in Group A. Alrighty, let's have a look at Group B. Well, in Group B, 24 is a fail, 28 is a pass, 29 is a pass, 34 is a pass. Those both fails, 32 is a pass, 29 is a pass, 37 is a pass, and 28 is a pass. So 1, 2, 3, 4, 5, 6, 7 who passed from Group B, and 3 who failed. Total of 10, which means that there were 7 students who failed in total, 18 students who failed in total, passed in total, and 25 students in total. So now that we've organized our data into a two-way table, now let's turn it into a percentage two-way table. So I'm going to drop that total next to the Group A and Group B and start working out some totals. Some percentages, sorry. So we've got pass, fail, total, and Group A and Group B. Alrighty. So for Group A, how many of them passed versus failed? Well, for Group A, the number of passed was 11 out of 15. The number who failed was 4 out of 15, and the total will be 15 out of 15. For Group B, 7 out of 10 passed, 3 out of 10 failed, and 10 out of 10 participated. So let's work out all of these percentages. Alrighty, so there is my percentage two-way table. So is there an association between age and passing? Well, Group A, who were the younger group, actually passed a little bit better. They actually passed by 3% more than Group B. And so then you can see the opposite is true for the failing. That 3% less of the younger group actually failed than the older group. Alrighty, so 73% of the younger students passed compared to 70% of the older students. But let's just make sure. The percentage difference is not huge here. It's only 3%. And we're talking about really small sizes, 15 compared to 10, 25 students. You imagine these percentages would be wildly different if just one more student from group B passed or one more student from group A failed. So there could be lots of other factors, including how much preparation time they got, how much teacher input they had, revision time, everything like that. So although we can see there is a slight association that the younger students tended to do better than the older students, that's not conclusive. This is just one piece of evidence that we're looking at here. Alrighty, so that's how we deal with percentage 2A tables. See you in the next one. Goodbye.